Previous session, we had discussed about the elevator angle to trim, elevator hinge movement, stick force, trim tabs, and stick force gradient. Let us move on to direction control and roll control in this session. Direction control. Direction control is achieved by a control surface called rudder located on the vertical tail. The rudder is a hinged flap forms the aft portion of the vertical tail. The size of the rudder is determined by the direction control requirements. The yawing moment produced by the rudder depends on the change in lift on the vertical tail due to deflection of rudder times its distance from its center of gravity. For a positive rudder deflection, a positive side force is created on the vertical moment, producing a negative yawing moment. Rudder requirement. Adverse yaw. When an aeroplane is balanced to execute a turning maneuver, the ailerons may create a yawing movement that opposes the turn. The rudder must be able to overcome the adverse yaw so that a coordinated turn can be achieved. The critical condition for adverse yaw occurs when the aeroplane is flying slow. Cross landings. To maintain alignment with the runway during a crosswind landing requires the pilot to fly the aeroplane at a side slip angle. The rudder must be powerful enough to permit the pilot to trim the aeroplane for the specified crosswinds. For transport aeroplanes, landing may be carried out for crosswinds up to 15.5 meters per second or 51 feet per second. Asymmetric power condition. The critical asymmetric power condition occurs for a multi-engine aeroplane when one engine fails at low flight speed. The rudder must be able to overcome the yawing moment produced by the asymmetric thrust arrangement. Spin recovery. Primary control for spin recovery in many aeroplanes is a powerful rudder. The rudder must be powerful enough to oppose the spin rotation. Roll is achieved by the differential deflection of small flaps called ailerons, which are located outboard on the wings, or by the use of spoilers. The basic principle behind these devices is to modify the span-wise lift distribution so that a moment is created above the axis. I hope you would have understood the direction control and roll control. Let us move on to the control systems in our next session. Thank you.